So adding, subtracting. Today we're dealing with real numbers, and maybe in parentheses I put add, sub. That's it. So what is a real number? Who thinks they can explain to me what a real number is? Mike, you got an idea? No? Dylan, you got an idea? Not a fake number? How about this? Maybe I'll give you some examples of fake numbers or not real numbers. Like 6 divided by 0.
Oh.
You can't divide by 0. Here's one you won't know yet, maybe, but like square root of negative 4. You can't do anything times itself to get a negative. Okay? That's not. So real numbers are, they include. So I'm going to write includes.
Can we write this on ours?
Yeah. Real numbers includes whole numbers. So like counting numbers 0, 1, 2, 3, 4, 5, 6, 7, 8. Integers. And this is a fun one. A lot of times we have the wrong definition of integers in our head. Anybody want to try to tell me what an integer is? You saw it for the first time last year. What is an integer? And guys, wrong answers are cool. That's where we grow, by the way. Get it wrong. That's good. It sticks. Anybody in Zoom have their hands up? What is an integer? I know you learned about them last year. Yes, you did. Nobody wants to? Okay. Nobody's going to take a shot? Usually I would encourage you with a shot at the hoop, but we're not allowed to do that right now. Okay, so.
What?
At the hoop. Integers are whole numbers and their opposites. So a lot of times we have the incorrect definition for integers in our head as negative numbers, because the first time you deal with negative numbers, you start using that word integers. But integers are all the whole numbers and their opposites. So 1, -1, 2, -2, 3, -3, 4, -4, all of them.
Oh, yeah, we did.
Notice, what did I not use in that integers? What kind of numbers? 1, -1, 2, -2. I'm missing like infinite number of numbers still. What kind of numbers am I missing? No, -0. What's between like 0 and 1?
Oh, decimals.
Yeah, fractions and decimals are also, all these numbers are real, okay? Fractions, decimals, integers, whole numbers, counting numbers, natural numbers. We're not going to go into the little nuanced differences, but so when we're dealing with adding and subtracting real numbers today. So add, addition and subtraction. Now when we're talking integers and stuff, that means we're going to be dealing with positives and negatives. Now you did this last year and you were good at it last year most likely. Some of us are going to be a little rusty. All right? And let me preface, the positives and negatives, I think memorizing rules is trash. Let me tell you why. Raise your hand if you think you're real likely to memorize this definition to know what to do next week if you were to have a quiz. To add negative numbers and positive numbers, you find the difference and use the larger absolute value to decide its sign. Is that something that's going to be easy to remember in 2 weeks to know what to do? No, dude. It's like, what does that mean? Absolute values and larger. And so I'm gonna show you a way to prove why the positives and negatives work like they do today. And then we're gonna have an easy concept-based approach to finding solutions. Okay, concept-based. I'm gonna use 2 words: fighting and hugging. I know it might be PG today. Fighting and hugging. All right, that's all you need for adding, subtracting integers or negatives and positives. We're gonna do a teeny bit of fraction work for a refresher today. But I'm going to assume that you know how to do operations with fractions and decimals since you're in algebra. Okay, so I'm going to start a pattern, an exploration pattern. And you need to extend it for me. So wherever there's a blank, you're going to fill in. And you're going to extend things. Make sense? So we're going to start with this. 4 plus 2. 4 plus 1. 4 plus 0. 4 plus blank. 4 plus blank, 4 plus blank. So you need to fill in all my blanks and extend a pattern. So I'm going to give you a second to do this right now on your own. You're writing this in your notes. You're filling in blanks, and you're filling in blanks. When you write it on your notes, Zoomers, you're filling in blanks, and you're filling in blanks. Okay? Extend the pattern. Mikey's going to help me out. So starting at the 4 plus 2, what do I have?
6.
6. 4 plus 1.
5.
4 plus 0.
Oh, I said
4. Mikey, how would you explain my sums? What's happening to my sums?
4. They're going down by 1.
I'm decreasing by 1. So what's happening to the number I'm adding by?
Going down by 1 also.
So it makes sense. If I'm adding 1 less, my answer is
1
less. Makes sense, right? Okay. So 1 less than the 0, if I'm going to extend that pattern down.
Is negative 1 in parentheses.
Yeah, it can be in parentheses, doesn't have to, but I like that organization approach. I like that.
And that equals
3. So, okay.
3. Negative 2. And that equals 2. Negative 1. And that equals 1.
Well, no, it'd be
Oh, negative 3 and that equals 1.
Okay. So you're going to notice our sums continue to decrease by 1 as the number we're adding by decreases by 1.
Wait, so, I have a question.
Yeah, I'm listening.
Okay, I need a total refresh because I need.
Well, but we just extended a pattern. 2, 1, 0, negative 1, negative 2,
So I have a
negative 1.
question, so then if it goes to like negative 5, then you would have to go down to a negative.
So let's do that. 4 plus negative 5. That would go down 2 from 1. So 1, 0, negative 1. So here's the deal. I summarize everything by calling it fighting or hugging. So when I have these two positives, they're on the same team. They're both positive. The positives, they're going to hug and make a bigger positive. Okay? Now, down here, we got a positive and negative. They throw down. All right? One positive. What happens with one positive, one negative?
They fight.
They fight and they cancel, right? So in that 4 and negative 2, who wins?
4.
The positive 4 wins by how many?
2.
It's easy as fighting and hugging. Right? Do you see how that's concept-based and that's easy to remember? The rules. When you have two different values, find the difference of their absolute values, and then the larger absolute value gets to keep its sign. How likely you're gonna? I used to have kids write that down in their notes. I can't believe it. Anyway, fighting and hugging. So we have another exploration to do. We're going to start with negative 4 plus 2, negative 4 plus 1, negative 4 plus 0, negative 4 plus blank, negative 4 plus blank, negative 4 plus blank. I want you to extend the pattern and fill out what I have here, friends. So again, these are, you're going to have 2. Those are 4s. I know they might look like Y's a little bit. I apologize. Those are 4s. So you're going to extend and fill in your patterns, and let's see what happens now that we have negatives and subtraction. I would love to get students to help me fill this out, but for the sake of time and pacing, I'm going to just kind of roll here, okay? But I like having, in fact, if class was like a normally thing, I'd be passing this around and everybody be pitching in. So I've got a 4 and a minus 2. My head operates here a little different. I see 4 positives and 2 negatives. That's what I don't change anything. I see 4 positives and 2 negatives. And this allows me to use the associative and commutative properties. Are 4 positive and 2 negatives, or are you going to fight or hug?
We're gonna. No, we're gonna fight.
Fight. 4 positives, 2 negatives. The 4 wins by 2. Okay? So here, I have 4 positives and 1 negative. So when I see subtraction, I'm just thinking positives and negatives. I don't mess around with that. I'm just positive negatives. So that one negative 1 kills 1 of the 4, gives me 3.
And then the 4 wins by 4.
4 wins by 4. Okay, so here's what next after 0 comes negative 1. But if I extend my pattern, 5. So what that means is this is the same thing as 4 plus 1. A minus negative just is a plus. So I never...
A minus and a minus.
Yeah, so just like in language arts, you know how you're not allowed to use double negatives in speech? Like, I don't have no money. Yeah, the reason you're not supposed to say that is if you don't have no money, you would have some money.
Yeah.
Okay,
Wait.
so you don't use double negatives in language.
Wait, I'm sorry.
For the same reason in math, because it makes it positive.
I get what you said. I just don't get the English.
If you don't have no money,
Oh.
you have some. So it changes the meaning, right? So
Southern accent.
So look what I do. Look what I do. I don't mess with the minus negative. I just do this. Because minus negative is actually a positive number. So I got 6 there and a plus 3 for 7. And it makes sense when you extend your pattern, right? So if you ever forget, you could set up this little experiment on the side if you don't remember what to do. I'm just fighting and hugging all the time, okay? So next, I'm looking on my right side. I see 4 negatives and 4 negatives. That's how I view this. So if I have 4 negatives and 4 negatives, are they fighting or hugging?
They're hugging.
They're hugging. And how many negatives am I going to have?
8.
8 negatives. Okay? Here, I got 4 negatives and 3 negatives.
Oh, so that's a -8.
Yeah.
Yo, I messed up.
Okay? 4 negatives and 2 negatives. 6 negatives. Tannen, one thing I want to say, it's a good mistake. It's a good mistake. I want mistakes. And guess what? You're going to learn that now. If you just sat there and didn't do anything, you wouldn't have learned it, right? I'm all about it. Okay, so after -2 comes -1. 4 negatives and 1 negative is 5 negatives. Down from 1, 0. That's just going to be -4. And then remember, the 2 negatives actually is what?
Positive.
Positive. So I'm going to put +1. And now I got -4 fighting +1.
And they went back 3, -4.
Yeah, and you know, notice the pattern. Down, up, not down 1. Up 1, up 1, up 1, up 1, up 1. Okay? So I'm always just trying to understand, is my number positive or is it negative? And does that mean it's going to fight or it's going to hug? Simple as that, instead of the crazy absolute value definition I used to have kids write down. All right? One's going to be easier than the other.
Is this
To
what
know
our
long
books
term.
look like?
Yeah, that's beautiful. All right. Now, just a couple other things. Just for some quick review. This is going to be really quick because my assumption is you know how to do these things, okay? So just for a real quick review, we're going to do something like 3 4/5 plus 2 5/7. And we're going to do something like 327.42 plus 6.8. Okay, now, these the positives and negatives I'm not going to mess with right now. They work the same way as integers, right? They either fight or hug, same exact way. You're either going to be combining them or subtracting them.
Is it 6.82?
6.8. Okay? So let's focus. I'm just going to roll through this quick. This will be on my YouTube, linked in the document tonight. But my expectation is you're in algebra. You know how to do fractions and decimals. If not, talk to me on the side and we can figure something out. But we have to have this for algebra. So with fractions, what's the first thing I need?
Common denominator.
Yeah, because otherwise you're adding things that aren't the same size. It'd be like throwing a bunch of change on the table and just counting each coin and saying I have that much money. It wouldn't make sense. They all have different values, right? So fifths are different than sevenths. So here I need a like denominator, and I'm going to use 35. And what I like to do is I like to set up my whole thing like this, where I know I'm using 35, and then I go concentrate on my numerators. That's just an organizational thing. I get everything out of my head I can and then focus on what I need. So I've got a 5 times 7 and a 4 times 7. So one thing that's really important to understand, 4/5 is 28/35. I didn't change the number, I just changed how it looked, right? Okay, I got times 5 times 5, that's 25. So now I'm going to add my whole numbers and my fractions. So 5 and 53. Just so you know, I can add 28 and 25 really quick because I do stuff like I move numbers around in my head to get 10s. So I put my 20s together to get 40. I use an 8 and 2 of my 5 to get to 50, and then the 3 left over for 53. So I like to give you my strategies for how I do the quick maths.
So do you
Okay?
have to reduce it?
Well, I simplify, yes, but we got to look at this. Yeah, I'm not done.
So 6/19 is
So one whole is 35 out of 35, right? So I got to take a whole out of there and put it over there for 6. And from 35 up to 53, 5 gets me to 40.
6 and
Oh, I don't need that 5 there. 5 gets me to 40, 13 more to 53, so 5 and 13 is 18.
And then you have to reduce that.
Well, 18's factors are 1, 2, 9, and 18, none of which are factors of 35. So I can't simplify that one. But yeah, good point. We do need to have things in simplest form. So that's the crash course. I picked some of the harder fraction work, but the expectation is you kind of. So when the negatives come into play, though, if one of these were negatives, we have to keep our positive and negatives, the fighting or hugging in mind, okay? All right, this next one I'm not even going to do, though. The big thing with decimals is lining up by decimal place, by your place of value, okay? I like to slap a 0 in an open spot. It's not a bet. You don't have to. And then it's just the standard addition algorithm, okay?
Wait, what?
334 and 222 and
334 and 22 hundredths.
Oh, I don't know.
But again, I know that's quick, but for algebra, we can't be doing fractions and decimals full blown, right? Because we're in algebra. So, this will be on YouTube tonight if you need to look at anything.